Assalamualaikum and very good day to everyone. My name is Nurshazwani Binti Rusli from UiTM Pahang. I'll be presenting my final year project entitled Optimization of Gas Chromatography-Mass Spectroscopy GCMS and a Headspace Solid Phase Microextraction SPME for the analysis of the extraction volatile organic compounds in Nigella Sativa seed oil under supervision Dr. Siti Raihan Binti Zakaria. What is Nigella Sativa seed oils? Nigella Sativa or black seed is a type of herb plants and also known as habatus sauda from the term Arabic in Malaysia. The latest study indicated that Nigella Sativa seed oil has various applications such as spice, food, additive and flavoring agent and traditional medicine by KB et al. 2020. Second, as recommended treatment which has immunotherapy activity and antiviral for sickness recovery by Koshak et al. 2021. Therefore, a proper extraction method need to be analysed for the extraction of Nigella Sativa seed oils component. Solid phase microextraction method for the extraction volatile organic compounds from previous study indicate that 1. The SPME technique enhance the volatile extraction from gas or liquid sample using the fused silica fiber and continues with the desorption of analyte to get the less abundant volatile in the Nigella Sativa seed by Farah et al. 2017. Nigella Sativa seed oil is composed of various volatile components with a unique taste of aroma. Thus, important to characterize the volatile component for further study in traditional medicine by KB et al. 2020. To achieve a good extraction efficiency and result in terms of accuracy and repeatability, the SPME method requires a few settings of some fundamental parameter by Farah et al. 2022. Thus, the optimization of SPME and GCMS method is chosen and be considered in this study. To use the solid phase microextraction technique in obtaining volatile organic compound and focusing on optimization of different parameters performed using multivariate technique. Next, the development of SPME method from this study can be used for further study, especially for Nigella Sativa seed oil and other complex samples for the development of chemical analysis and science. The objective of this study are first to optimize the GCMS condition, which is oven temperature programming and carrier gas flow of volatile organic compounds content. Second, to evaluate the efficiency of different types of solid phase microextraction fibers on the extraction of volatile organic compound in Nigella Sativa seed oil. Third, to optimize the SPE condition, extraction temperature and extraction time of volatile organic compounds contained in Nigella Sativa seed oil using responsive phase method (RSM). Fourth, to compare the volatile profile of 4 different brands of Nigella Sativa seed oil using the optimization of GCMS and SPME with the chemical markers from previous study for general authentication of Nigella Sativa seed oil. Moving to the literature review, there is 2 methods that will be used, which is headspace solid phase microextraction. SPME is a method of solvent-free, non-extractive extraction technique in which a small proportion of the target analyte is extracted from the sample matrix in comparison to the solvent extraction by Genger et al. 2000. Second is gas chromatography-mass spectroscopy, a study of non-targeted metabolomic approach for analyzing metabolite content, a polar and non-polar fraction from a raw and roasted seed were achieved using the GCMS. Next is method for the analysis of Nigella Sativa seed oil sample by previous study. In study by Saleh 2018, instrument analysis used was GCMS, analyzed with a type of extraction method that seed were grounded to the powder using electric grinder for 5 minutes, then soaked overnight in distilled water or methanol, preparation of the aqueous and methanolic extract. And the volatile extract was beta-pinene, thymoquinone, palmitic acid, oleic acid, thymol. Study by Dolakah et al. 2022, instrument analysis used was one-way independent measure ANOVA and Kruskal-Wiley's test with types of extraction method that 20 ml of the Nigella Sativa were hydrodistilled and the volatile compound extracted was thymoquinone, thymol, oleic acid, alpha-helendrine, carbohydrate and proteins. Study from Dali et al. 2021, the analysis was performed with ANOVA followed by 2 tests with post-hoc multiple comparison threshold 5%, with type of extraction method by differentiated in Hudson using the Sohlett apparatus with compound collected was steroid, tannin, phenol, alkaloid, flavonoid, encardiol and glycoside. Next is the overview of the method development. As we can see here, the optimization is divided by 2, which is gas chromatography parameter, which is oven temperature and carrier gas flow rate. And the SPME parameter by starting with 2 stages, starting with determine the efficient SPME fiber from 4 types of different fiber, and second stage is optimization of the significant factor, which is extraction temperature and time using the RSM. This continue with analysis of the Nigella Sativa seed oil sample using the GCMS and SPME. Here are the method in determination of VOC from the Nigella Sativa seed oils. From the result and discussion, for Objective 1, there is 4 points. For temperature programming using Farad et al. 2017, oven temperature program reference, the optimization GC continue with different rate and hold time to get the peak that is not overlapped and has the baseline shift error as can be seen in the chromatogram A, B, C, D, E and F. The baseline level must be removed to minimize variation caused by the change in the rotation time due to inconsistent sample preparation method. MD Gazi et al. 2022. After 6 trials with the rate RAM 1 at 10 degrees Celsius per minute with hold time 2 minutes and RAM 2 at 15 degrees Celsius per minute with hold time 2 minutes, which can see in the chromatogram F that the overlap and the baseline shift error has decreased. According to studies, because many compounds have identical volatile and have value in the similar region of the chromatogram, the temperature program was modified to achieve a better expression such as to improve the early portion of the chromatogram retention time. The second round will investigate on the effect of the suppression, Dextran and Cisco 2022. Better suppression will give better peak. Thus, the optimization have to increase the suppression to achieve the better suppression on the chromatogram. Development of column flow rate for GCMS. For the next parameter to optimize are the column flow rate. The fluctuation of column flow rate are done in the experiment as can be seen in the chromatogram A, B, C and D. The decrease of the carrier gas flow rate, the overlapping peak and the abundance of the peak are also decreased. The column flow rate at 0.9 ml per min show that the abundance of the peak has disappeared. This means that the column flow rate affect the abundance of the peak, thus give the nice chromatogram for the multivariate analysis compared with other GC flow rate done. From the analysis of column flow rate change caused in the chain of the chromatogram peak, this can be justified by on a study by Lenin Pen and members that good peak shade and height detection sensitivity can be ensured by choosing the appropriate column that match to the target analyte properties such as polarity and volatility. Moreover, at low flow rate, the component and stationary phase could interact adequately, and according to the 1-dimensional equation, there is an optimum flow rate when the theoretical plate height was the lowest and the suppression effect the greatest. Han et al. 2019. This because the column flow rate is directly proportional with suppression compound, which decreasing the column flow rate will increase the suppression, thus reduce the overlapping peak. For Objective 2, there is 2 things to be discussed. 4 different types of fiber are used, which is 100 micrometer polydimethylsiloxane, 65 micrometer polydimethylsiloxane and benzene, and 85 micrometer polyacrylate, and 50-30 polydimethylsiloxane, benzene and carboxane. The polarity different of the fiber cause different on suppression on the chromatogram. The PDMS fiber are non-polar fiber, PA are polar fiber, PDMS DVB and mixed PDMS DVB carboxane are bipolar fiber. From the data, the VOC obtained each fiber are PDMS detect 10 VOC, PDMS DVB obtain 11 VOC, PA obtain 8 VOC and mixed fiber obtain 12 VOC. Next is choosing the most efficient fiber from the VOC obtained. The graph show among the SPME fiber test, the PDMS DVB carboxane are evaluated as the most effective fiber to extract VOC of Nigella Sativa oil, with total area collected of the fiber was 6.38 times time power of 8, with 12 VOC detected that higher from the rest of the fiber. For Objective 3, there are 3 things to be discussed. Study by Caroline Rodriguez Carvalho on the extraction E. visosa used experimental design on the factor of extraction temperature and extraction time, and the weight bite of the flower resulting extraction temperature gives significant impact. Meanwhile, the weight bite did not contribute any response according to the high p-value and a low lack of fit. Thus, only 2 significant factors were chosen, which is the extraction temperature and extraction time. Extraction temperature and extraction time, this can be seen in the 3D surface plot. The total pitch area of the compound obtained from this study increased with the temperature and started to decrease after the extraction temperature reached at 40.56 degrees Celsius, and also for the extraction time it is increased until 31.11 and decreased after that. Thus, the most optimal extraction temperature Nigella Sativa oil are at 40.56 degrees Celsius, and the optimal time for the extraction time are at 31.11 minute with the expected collected total peak area at the 5.090 times 10 power of 8. The desirability of the design experiment is 1. This means that 1 represents that the design is totally desirable or ideal value response. Summary of the central composite design of the Nigella Sativa oil significant factor. The effect of the independent variable of the extraction temperature and the extraction time was evaluated by the second order, which is quadratic. Moreover, the adequacy of the model was determined using the model analysis, which is led of fit test, and the coefficient of determination are squared. The ANOVA results show that the model was significant, P low than 0.05, and with significant lack of fit, P higher than 0.05. For the fourth objective, there is two things to be discussed. There were 31 VOC total collected in the 4 samples of different brands in 3 run times. Sample A contained 21 VOC, sample B contained 5 VOC, sample C contained 11 VOC, sample D contained 9 VOC, which is the component are high at 80% in the compound. All 4 brands are the authentic of the Nigella sativa seed oil. They are sold in the market. The chemical markers for Nigella sativa, according to the finding, is thymoquinone, pisimine, cis-4-methoxy, thujane, longifolin, othymol, alpha-thujine, osamine, 4-octacylmorpholin, and dimethylsalendiol. According to study, pisimine was found to be the most abundant component in Bangladesh and Indian Nigella sativa seed, which consistent with their finding, even though some study identified thymoquinone as the key component in Nigella sativa essential oil by Kabil et al. 2020. Interestingly, are the same result as the finding as the pisimine compound are found in the all sample, but thymoquinone sample are found in the 3 sample only, even though it is main component. Thus, this show that the analysis of Nigella sativa seed oil VOC comparison determine the authenticity of the sample. Among the SPME fiber test, PDMS, GVB, carboxane are evaluated as the most effective fiber to extract VOC of Nigella sativa seed oil, with the total area collected for the fiber used was 6.38 times 10 power of 8, and the 12 VOC detected that is higher than the rest of fiber. Optimized extraction temperature and extraction time, the optimum are 40.56 degrees Celsius, and the optimum time for the extraction time are at 31.11 minutes, with the expected collected total peak area at 5.109 times 10 power of 8. The analysis are done by comparing each sample through the main component of Nigella sativa seed oil, which is thymoquinone, pisimine, cis-4-methoxy, thujane, longifolin, othymol, alpha-thujine, osamine, 4-octadecylmorpholin, and dimethylsalendiol. There are few recommendations that can be done to enhance the finding of volatile organic compound in Nigella sativa seed oil. The 8 significant parameters of SPME could be used to have more findings, which are salt addition, sample weight, stirring rate, sample pH, desorption time, desorption temperature, extraction temperature, and extraction time. The screening of significant factor can be done using the packet movement to have more specific significant factor before carry out the RSM-CCD. Finally, it is recommended to broaden the finding by examining Nigella sativa sample from different countries to trace the origin of the plants. That's all from me. Thank you.